Hello students, this is Ashish. I am your maths lecturer. So today we are going to study the application of derivative, of which the most important topic is the maximum, which is always occurs in the JEE exam. Okay. So what are the points we are going to study in maximum? That is the local maxima, local minima, global maxima and the global minima. So by understanding these points, we can fully solve all types of problems from the JEEs. Okay. So this point sounds like a little bit complicated. There is a local, global. So what are these concepts? So to understand these points, just go through an example. Okay. Suppose in a school there are multiple sections. Section A, Section B and Section C. Okay. So out of these sections, what we have conducted one similar exam for all these three sections, and for that exam we have secured two students. Okay, from each individual section we have secured the two students who has obtained the highest marks as well as the lowest marks. Okay. From each section, what we have done, we have obtained one individual student who has secured the highest marks as well as the lowest marks. So, from each individual section's point of view, what I am saying is from each individual section's point of view, whoever has got the highest marks will be referred as the local maxima. And whoever has secured the lowest marks in that exam will be known as a local minimum. So these will be referred as a local maxima and local minimum. So what are the global maxima and global minimum? So if we compare all the students from each individual section who are secured the highest marks, so that means the global maxima is the maximum value from the highest values obtained in the given interval. That means suppose this is person X, this is person Y and this is person Z. Okay. So out of X, Y and Z, whoever has secured the highest marks will be known as the global maximum. So maximum out of all available local maxima value will be known as the global maximum. Similarly, what will be the global minimum? So, out of all the local minimum values, whoever has secured the least value will be known as the global minimum. Okay. So, the definition for the global minimum will be the minimum value out of all available local minima values. Out of all local minima values. So these are the basic concepts regarding the local maxima, local minima, global maxima and global minima. So to summarize this concept, always remember, if we are going to study a function in a particular limited period or a limited, limited domain. So in that domain, whatever the highest and the lowest values will be there, those will be known as the local and maxima and local minima. So if we extend the function in a large scale, that means if we extend the domain to the larger extent, then we can obtain the multiple local maximum and multiple local minimum values. So out of available maximum local maximum values, whoever has the highest value will be known as the global maxima, and out of all the least values, whoever has secured the least value will be known as the global. That is the concept. Okay. So to find the maximum or the minimum values of a function in a particular interval, what we need to find where the function's behavior changes. So these points will be known as the critical points. These will be known as the critical points. How we can find the critical points? The first criteria is where the first order derivative is equivalent to 0, or the second criteria is where the function is not defined, or the function is discontinuous, or the function is non-differentiable. Okay, these will be the points which will gives me the critical points, and all those critical points we are going to find out where the function will be giving us the maximum value and the function will be giving us the minimum value. So if there is one definition already available, then why we are going for the next definition? So for that, consider an example. Suppose f of x is 1 upon x. F of x is 1 upon x. So what will be the derivative of that function? That derivative will be minus 1 upon x square. So by the first definition, what we can obtain? That f dash of x is equal to 0. So after solving this, what we can obtain? That minus 1 is equal to 0 by shifting x square to the right hand side. Okay, 0 multiplied by any quantity is always equivalent to 0. But is this reality? No, this is not possible. So in some cases, the first order derivative test fails us. That's why we are going to implement these conditions, okay, such that the function is not defined. So how we can find the critical point in this function? Suppose if x is equal to 0, the function will not to be defined. The function is not defined. That means at that point, the behavior of a function will be changing. So that will be our critical point. Okay. So first we need to find the critical points of a function in a given interval, and after that, from that critical point, we are going to determine whether that critical point is giving me the maximum value or the minimum value. So to find which point gives me the highest value and which point gives me the least value, we have two individual methods. First method is known as the first order derivative test, and second is known as the second derivative test. So first we will look at the first derivative test. Before that, just we are going to revise some basic concepts from increasing and decreasing. So that will be, if the given function is like this, suppose this is a given function and this is a point C, and this will be my C minus h, and this will be my C plus h, where h is the smallest interval. Okay, suppose from the C minus h to C, we have taken any point and we have drawn a tangent at that point. Okay, what is a tangent? Tangent is a line which is having only one common point with the line and a given curve. Okay, what is the slope of a tangent? That we have already studied. That slope of a tangent is the first order derivative. Okay, so here if I need to find what are the possible values, so we are going to just implement the basic concepts from the trigonometry. So slope can be defined as tan theta, where theta is the inclination made by the line with the positive direction of x-axis. So here theta, what is the theta? Here theta is acute angle, which must be lying between 0 to pi by 2. That means theta belongs to the first quadrant, and in first quadrant tan theta is always positive. That means my slope is positive. That means my first order derivative is positive. Okay. If we take an interval from C to C plus h and we have taken any point and we have drawn a tangent there, it will be like this. So consider alpha will be the angle made by this tangent with the positive direction of x-axis. So here alpha must be lying between pi by 2 to pi. That means alpha belongs to the second quadrant. Okay, in second quadrant tan theta is always negative. That means my slope is negative, which will gives me my first order derivative to be the negative values. So how we can find the critical point? Just look at this example. Here the slopes are positive. That means f dash of x is greater than 0. In this interval, f dash of x is less than 0. That means here we have the negative value of the slope, and exactly there will be a point in the interval where the tangent will be parallel to the x-axis. Tangent is parallel to x-axis. So what results into that is, if a line is parallel to the x-axis, that means the angle made by that line with the positive direction of x-axis will be 0. So what is the slope? Slope is a tangent of that angle. That means slope is equal to tan 0, which will give me the 0. So how we can define these are the critical points? Because from this point the behavior of a function changes. That's why these are known as the critical points. And critical points are also known as the stationary points or the turning points. How these are known as the turning points? Just look at the example. That means at these points the graph will be changing its direction. That's why these are known as the turning points. This is a concept from increasing decreasing that we are going to implement in our maxima minima concept. Okay. After understanding what is a critical point and how we have identified the critical points and how we can find the maximum and minimum value at those critical points, first question is how? That is the best question, which is still unanswered. So we are going to implement the first derivative test. So this is the first derivative test. So how we can use this test? So first we need to find the critical points. That means the derivative of a function must be equivalent to 0. Suppose f dash of x equal to 0 gives me some values, that's c1, c2, c3. These are the values in the given interval where the slope at these points is equal to 0. Slope of a tangent is equivalent to 0. So out of these points, how we can find that? So for that, we are going to implement either inequality concept or the wavy curve method. So how that is defined? Suppose they have given us a particular interval. So that will be my least value, lower limit will be my least value, and upper limit will be the maximum value. Okay. Suppose the interval is not defined. Then what we are going to do is we are going to take these points from minus infinity to plus infinity. And after that, what we are going to use? We are going to use the wavy curve method. That means we already considered that this is positive, negative, plus, minus. Suppose the wavy curve method is applicable just like this. Then we can use the previous concept, that is the increasing decreasing concept. What we have studied, that if a function, that means my first order derivative changes from positive to negative. This is a positive and this is a negative. That means that point gives me the maximum value in the interval. And suppose for f dash of x changes from negative to positive, so it will be like this. That means the tangent is first is negative, then the slope of a tangent is positive. That means it is giving me the minimum value. So we are going to implement these concepts from increasing decreasing here. So what will be the value of C1? Either this will be the local minimum or local maximum. Just look at this. What we have written, that f dash of x changes from minus to plus. That means at that point the function gives me the minimum value. So it will be like this. So C1 is giving me the minimum value. C1 is giving me the minimum value. At C2, f dash of x is changing from positive to negative. That means this will be giving me the maximum value. And again here, C3 changing from minus to plus. So this will be the minimum value. That means these are my two local minimas. And out of these two, which value is giving me the least among these two will be known as the global minimum. Okay, that's it. That's the simple method we are going to use. But in some examples, this technique is not applicable. Okay, if the algebraic function is there or some exponential functions are there, then the wavy curve method or the inequality is applicable. That will be the easiest thing. But for some trigonometric function, it will be lot more the complicated thing. So for that concept, what we are going to use, we will be using the second derivative test. Okay. So if there is a confusion while solving the problem in between the first derivative test and second derivative test, always remember the second derivative test is the proper method. It is a little bit of lengthy method, but it will give me the accurate result, and there will be no such complicated thing just like the wavy curve method, something like this. Okay. So what are the criteria for the second derivative test? First, here also. First, define the function. So how we can define the function? So whatever the word problem is there, so in that problem, whatever the requirement is there, that means if a question is find the maximum profit or the minimum cost, the profit is my function, the cost is my function. That means f of x is defined by the example. Okay. So after that, we will find the critical points. How we can find the critical points? That we will use the definition of a critical point. In maximum cases, we are going to use this definition, that f dash of x equal to 0. And if f dash of x equal to 0 is not applicable, we are going to use the second definition, which will be the very rarest option. Okay. So after finding the critical point, what we are going to do, we are going to find the second order derivative test. That's why it is known as second derivative test. Okay. We are going to use the second derivative test. Suppose from the critical point, we have obtained two critical points, that is C1 and C2. After finding the second derivative test, we are going to put those values in the second derivative test. Here, the most important and how to remember this technique is the very easy. Okay, consider this equality. Suppose f dash of x is a negative value. F dash of x gives me negative value. That means f of x will be giving me the maximum value. F dash of x and f of x are inversely proportional. Consider this. So this is the very easy technique to remember. Okay, if f dash of x is a negative, then f of x is a maximum. That means if f dash of c1 is less than 0, f double dash of c1 is less than 0, that means f of x is maximum at x equal to c1. And if the f dash of x is a positive, that means the f of x will be giving me the least value. Okay, if this is positive, that means f of x is minimum at x equal to c. So here, such techniques are not going to ignore. Okay. To understand these concepts very properly, we are going to take one example, very easy example. Okay. Suppose they have given us a function that x cubed minus 6x squared plus 9x plus 50, something like this. There is a function. Okay. So in this function, what they have told us to find the maximum value and the minimum value of a function. Minimum value of a function. If they have asked us only the maximum or the minimum, that means what they are going to ask, they are asking about the absolute maxima and absolute minima. Okay, and the absolute maxima is known as the global maxima and the absolute minima is known as the global minima. Unless and until they have used the word local, we are not going to entertain the local maxima and global minima. We are only going to find the global maxima and global minima. So how we can find this? So what we have studied? We have studied the two individual tests. So first is our first order derivative test, and our second is the second order derivative test. Okay. So let's see the same example from both the test point of view. What they told us in first order derivative test? From function, first find the first order derivative. Okay, so this will be my 3x squared minus 16x plus 9, and the derivative of constant is equal to 0. After simplification, that means 6 squared taking 3 common, it will be giving me x square minus 4x plus 3. So after factorizing, it will be x minus 3, x minus 1, f dash of x. What were the critical points? Where the f dash of x will be equal to 0. So consider f dash of x equal to 0. 3 is not equal to 0. That is the common sense. That means either this bracket is 0 or this bracket is 0. Which will give me the critical point x equal to 3 or x equal to 1. So in the first order derivative test, what we are going to use? Either the inequality or the wavy curve method. So here the wavy curve will be like this, 1 and 3. Okay. First we will check the indices of a bracket. What we have studied in the wavy curve, that always on the right hand side the graph is positive, and if the order of a bracket is an odd number, then the function will be changing its sign. So how we have obtained x equal to 0 from this bracket? What is the power of this bracket? Which is a 1, which is an odd number. That means my function will be changing its value from positive to negative. And how we have obtained x equal to 1? From this bracket. Okay, what is the power of this bracket? Which is 1, which is an odd number. That means it will change its behavior again. That is from minus to plus. Either use the basic common sense, that means the f dash of x is changing from plus to minus or minus to plus, that sense, or we have used the increasing decreasing concept. From that we can find the maximum or minimum. What is this? This is f dash of x changing the sign from positive to negative. So this will be positive, this will be negative. So this will be the point of maxima, and this will be minus to plus. So that means the graph is like this. Here the slope is negative, here the slope is positive. That means 3 is my point of minima. Okay, this we can obtain from the first order derivatives. For some students, this will be look like very complicated. They will say, these are the complicated things. Just give us a simplified method. Okay, then you can always go for the second derivative test, which is very easy. So how we can proceed with that? First, define the f of x. That is, they are already defined. Second step is find f dash of x equal to 0. By taking f dash of x equal to 0, we have obtained already the critical points. So from f dash of x, here it is 3 times. This is 3x squared minus 12x plus 9, and critical points are 1 and critical points are 9. In the second order derivative test, what we are going to find? We are going to find the second order derivative from the first order derivative. That means we are going to differentiate f dash of x again. So my second order derivative will be, this is 6x minus 1. So taking 6 common, it will be giving me x minus 2. What they have told us? Put those critical points into the second order derivative. So f dash of 1. So this will be 1 minus 2. My point is whether this second order derivative is giving me the positive value or a negative value. That is the only my requirement. Okay, I am not interested in its value, absolute value. I am interested only in its sign. Okay, so 1 minus 2 is minus. So if we calculate, this will be minus. My major concern is whether this is giving me the positive or negative value. F double dash of 3. So 6, 3 minus 2 is 1, 1 into 6 is 6, which is 0. What I told you, take f dash of x and f of x as equality. If f dash of x is a negative, that means f of x is maximum. F dash of x is negative, that means from this we can conclude that f of x is maximum at x equal to 1. Okay, and if the f dash of x is positive, that means f of x is negative. So from this we can conclude that f of x is minimum at x equal to. So these are the same conclusions we can obtain in the first method. Here also, at x equal to 1, the function is giving me the maximum value, and at x equal to 3, the function is giving me the minimum. This is the way for finding the maximum and the minimum value of a function. This is very basic example. Okay, just go through this example, then we can proceed for the higher difficulty.